particular talk is going to be based on this particular quote I found from the Anthropic engineering team, right? So Anthropic is one of the best models and the best team in the world, and they themselves are telling the models are ready, but our architecture is not, right? Even the governance layer is definitely not, right? And I'll explain each layer why it is important and how it is going to help us define and create a production ready architecture, right? So a little introduction about myself. I'm an enterprise architect at EY. EY is the Big Four consultant company. I do tech strategy. I worked on digital transformations, greenfield implementations, brownfield implementations. Since 2 years working on AI. The AI strategy and implementation is what we do at EY. And I'm a problem solver and an AI tech enthusiast. And all the views are personal, not related to any company, right? So before we get started, I wanted to set the foundation, right? Like if I ask 10 developers what is an agent, right? Everybody has their own definition, right? Someone will tell a complex chatbot is my agent, right? Or an automation is an agent. But for the next 45 minutes, I want all of us to be in the same page, having this as a definition, right? So agent is a software that perceives the environment, right? It understands what are the tools it has, what are the commands it has, what memory it can access, it has some reasoning, right? So it will iterate through. I think this one, the USB is not this one, okay. This is not connected, right? It's okay, it's okay. Okay, so agent is not a chatbot, it's not an automation system. Agent is the one which can perceive, right? It can reason, it can act, and it can evaluate, and then it will repeat until the goal is achieved, right? So this is the basic definition which we all do align on, right? So then comes the multi-agent system, right? Why do we, so again, this is definition part, I want to, all of us to have to be on the same page, right? So agent is the one which has access to all the tools and it has a specific goal, right? So to take this to the next level, we have this multi-agent system. So what multi-agent system is a network of agents which are all autonomous, right? So each agent has some specialized activity that it does, and then there is an orchestrator which will actually make all these agents to achieve a specific goal, right? So the key components or the key characteristics of agents will be the 5 elements what I mentioned, right? It's an autonomous agent where it can act independently. There is no dependency between the agents, and it has a specialized role. So it can be a research agent, it can be a code agent, it can be a refund agent, right? So there are different specialized roles it will be doing. It's not independently, it will do those activities. And then you have a coordination layer. Without coordination layer, I think agents will hallucinate, and then you will be thinking models are not ready, right? So that's where the coordination layer is another key aspect, the fundamental aspect. And then next one is the shared memory. So all these agents will have a shared memory. So what does the shared memory mean is, they share the context. It's not the complete conversation or the full 200 lines from what you are writing, right? It's the context that is going to be shared across these agents, so they know what activity each agent has to do and what are the important things it has to access. And most important, governance layer. This is where I think even in the recent times you would have seen some of the agents have gone to production and then deleted data, right? So without governance layer, we have to define those boundaries, otherwise agents will do their own, right? It has its own way of thinking, and then it will create unnecessary trouble for all of us. So governance layer is pretty important. We need to define those trust boundaries, blast radius, and then audit that. Why it has done, why what it is doing, and then make the agents to be on production. So following that is like why we need multiple agents, right? So if an agent can reach a specific goal, why do we need multi-agents, right? So multiple agents are needed because the single agent has limitations. If you see on your left, those are the limitations of a single agent, right? So if you have a complex activity that has to be done for an agent, so let's say it has to process 500 pages of legal document, validate with the internal policies, and then validate with the Indian government rules, and then come up with an output. The context window is not going to be sufficient. So the context window ceilings will hit, and also there is no specialization. So what happens is, if you put any generalist, right? So LLMs are generalists. they are not specialists. Until unless you define the scope and then say you are this particular character, right, or the lead position, whatever, right, you define the scope, then it performs very well. If you, so any specialist, even in our regular terms also, right, anybody who has a depth of domain knowledge will always outperform a generalist, right. So specialization is what is missing in the single agent concept. And then parallelism, we can't do things in parallel, it has to be sequential. If it is a single agent, it is going to be sequential, and then it will take a lot of time for all of us to use. And if you are implementing something on production, latency is top notch important, right? Because you are giving this solution to some end users or something, and we can't expect them to just wait for 1 minute and then watch your screen and then say, okay, LLM is thinking, right? So serialization is another problem what it has. And then single point of failure. So if you have a single agent, it can talk to only specific model, and it will hallucinate, means it will drift away by 30-40%, and then we don't even know what's happening, right? So it will create a single point of failure, and there is no validation and guardrail that is happening. So all those four is what we will solve with a multi-agent, right? So we'll get more into this. And to just say, I think now we are clear on the basics, like what is an agent, multi-agent, why multi-agent. So now I want to show how these multi-agents are solving real world problems, right? So these are all source based. So first one is Klarna. So Klarna is a Sweden based fintech company. So what they have achieved is amazing, right? Like, so they have done like 1.5 years ago using a multi-agent solution. They have created a customer support agent, right? So if any issues happen, they have a audit agent, refund agent, then classifying the tickets, and then understanding what is the customer problem, intent classifier, right? So it does the complete work of 700 agents, right? So they have replaced 700 agents work with a 20 plus agents what they have created, and this whole coordination, governance where everything is created, and then they are able to achieve the automation and the time required, right? So these are the few statistics I want to show you all. So the big thing is like they were able to save 40 million by investing some 3 million. Developing this particular multi-agent solution was like some 3 million cost, and then their profit was, or the return on investment was 40 million, which is like some almost 15 to 20x, right? So nobody can imagine that kind of, imagine the CFO, how he would be in front of the boardroom, right? So he would be very happy. And then the time taken, right? So usually the problems, this particular team used to take some 11 minutes. Once these agents are implemented, it started taking 2 minutes only. The resolution time has drastically reduced, the customer satisfaction has increased, revenues have grown up, and then it's a win-win situation for everybody, right? And then there are multiple agents here, like I was explaining. So there is a triage agent which will understand what's the issue of the customer. Then there is a refund agent, if it is needed, it will generate. Then there is an accounting agent which will verify whether it has sufficient balance, whether the orders are there. And then there is a compliance agent, right? So compliance agent is pretty important here, because you are dealing with end customers and you should not refund to the person who is not eligible for that, or you are not giving refund to an eligible person, right? So that compliance agent is the one which will ensure everything is aligned, and then it's working as per the policies of this particular company, right? So that's the first use case, which shows that multi-agents are pretty effective. Following that is Coinbase. I think many people would know Coinbase. It's the cryptocurrency exchange solution. So their engineering team, right? So what they have done is amazing. So again, so it's a software factory. So they have created agents for product engineering. They have created agents for reviewing the code. They have created agents for writing the code. So they have created agents across the software lifecycle. And then if you prompt, it will create the solution. You have to review, and then once you approve, then it will push. So the solution or the development life cycle, right? So they used to take months, now it's happening in days, right? So it's all in like 1 year ago. All the case studies I'm talking is all 1 year ago, and then it's not just theory, right? So we are already in AI agent stage, and I think it's pretty important to understand how to define our production solutions, right? So following that, the last one, Anthropic. So without Anthropic, I think agents are not there. So the key thing is they have created a research and knowledge multi-agent, right? So what it does is, they have defined the lead agent is the one which is like Opus 4.6, right? So Opus 4.6 is the best model what we have, right? So this case study I have picked up because it explains why multi-agent is important. So the Opus 4.4, which is supposed to be like Oxford, Stanford kind of graduate, it was not able to solve specific problems, right? Like in this specific scenario, what they explained is, they wanted to identify who are the board members of all the listed companies in S&P, BSE 500 kind of S&P 500, right? The Opus 4.5, the best model, it's not able to do that activity. Once they have broken down into multi-agents, so they have created some 3 to 5 agents, and the sub-agents are at lower model, Sonnet, right? So they have used Sonnet, and the lead agent or the planning agent is at Opus. So using this Opus, which will only plan and then tell the sub-agents to do what activities has to be done, they were able to achieve it in 90% faster time, right? So if Opus would have, like, they have to refine, fine-tune everything, that would have taken some 3-4 days. But with this multi-agent concept, they were able to achieve it in much lesser time. And also the accuracy was 90% better than a direct single model, right? So that's what it is. And again, a big asterisk mark is the tokens will be much higher, right? So we have to think ourselves, just because a multi-agent is a fancy word, I use it, right? So that should not be the approach. We should think the use case should be complex enough for us to use these multi-agents, right? Because the token usage is high, and then you should show the ROI to your team, right? So that's what it's going to be at the end of the day.
I have a very basic question.
Yeah, please.
Whenever I query an LLM, in the sense the web interface,
Yeah.
either Claude or Gemini or ChatGPT,
Okay.
I tell it, write me a code that does this.
Okay.
Does that mean it is using agents in the back?
Now, recent time it started using agents. Previously it was not.
So when you do something Claude, say, do this, read the document for me and provide me a summary. Say, okay, I'm reading a skills document, reading docx, reading PDF, reading this.
Correct, yes.
Are those sort of what you can call it as agents?
No,
Are
okay.
skills different from agents? Are they different from forms?
Okay, yeah. So, okay, to baseline on this, all LLMs are the, so it has a basic understanding of the whole, I think attention is all we need, we know how LLMs work, right? So to make it more specific for the specific context, what they do is, it's all wrappers on top of the LLM what they have, which is Opus, Claude, all different models what they have. And then skills are mainly to give instructions, saying that, okay, to generate an output, right, whether it should be HTML file or PDF style, what should be my definition of output, what it should contain, right? So LLM can generate you an output which is of 30-40 pages also. So until unless you define a skill saying that how I should generate this output, it won't generate in the required format. So the same prompt with the same the outputs will be very different previously. Now at least it is trying to standardize because of the skills that are available. Sub-agents are, or the multi-agents, what I am talking about is, they do a specific task. So now let's say,
They don't thought that go to this particular website, fetch me this.
correct. So that's a tool. Okay. So when you say go and search in website, so there could be an agent which can do web searches, and then there could be one which will summarize the information it has found. Right, so the web search agent, will call it tool, which will crawl the websites and then bring that information and then pass to another agent saying that now this is the information, you refine it and then summarize. So the other agent will fetch this information, summarize and then give it back to you. This is the information.
That would be an agent based.
Yes, yes. It depends on the complexity of the task, right? So if you can define a problem and if that problem can be done in parallel mode, then for each parallel mode you will have an agent. You can have an agent. And type of the problem, right? So web search is one type of activity, right? And then writing to PDF is another kind of activity. So based on the activity you will have different agents.
And each agent can use a different LLM.
Yes, perfectly. That's what the advantage of having different
So I
agents.
can basically optimize it that is for tasks
Yes.
that I'm sure
Correct.
require only smaller stuff, I use small
Yes.
agents, go for it.
Yes.
And then for the
So now that's what is happening in Claude Code also. So for planning, designing, you use Opus. But generating the code, you will use lower models, which are like 0.25 usage tokens. So it depends on the type of complexity and activity.
This like, sorry, I'm taking
Yeah.
I just have this question. I think it's what better for the better
Yeah.
audience.
Sure.
The various tools that people are using, Claude for code writing, Gemini for code writing, ChatGPT.
Yeah.
Are people seeing differences between the code that's written? I saw that, for example, I asked Gemini to write some Python code and it was not at all following package stuff. Not at all.
Yeah.
Bad formatting, bad everything, मतलब वो package की जो guidelines है वो totally break करता है.
Right. So see, eventually, even if you go to Claude, now we can use Codex, which is OpenAPI's model, right? So for all this agentic coding, what we are using, Claude, the Factory.ai, Cursor agents, right? All these agents, they have their own recipe. Okay, how do I manage my context? How do I create my plan? Right? All that is the recipe they have. LLM is always same, right? The model is still same. So Cursor supports a 1 million context for your code, but other models will not support it. Will support a lesser context. And then how they are compressing the session, right? So for a longer session, so there is some problem called lost in the middle. So there is a paper on that saying that if you, even though the context is 1 million, after 500k, once you reach your 50% of that particular context, it is lost, right? It starts hallucinating. It will not understand the first line what you are wrote, right? So that's how they start creating memories. So the agentic coding architecture is again different story altogether. It will start creating the memories, what it has to store. It will start compressing the session before it reaches the context, the limits of the tokens. And then it will call the required APIs, tools, and for specific activities, it won't use LLM at all, right? Like how morning session, there is a date formatting or date response tool, right? So for that, we should not even call LLM, right? It's a date is not required to be called like for an LLM. So it will call the tool, get the output, and then show it, right? So they efficiently manage the whole process. So they are very code native, they know how to make things happen, right? And then they compress the code also, like you might write 1000 lines of code and 2000 lines of comments, but they are smart enough to remove the comments and then push only the code, right? So they have their ways of doing it. Like, so the agentic coding itself is very interesting topic. So then moving to the next one, right? So the first thing I wanted to, the next we'll shift gears, right? So while designing the production grade architecture for multi-agents, the common nomenclature everybody says agents are my new microservices, right? I have a different view, it's not microservice. So understanding, we all can think, okay, it's a multi-agent can be a small piece of activity which is doing some specific task, but it's not microservice. I'll tell you the reasons. And when we are designing, we have to rethink, re-baseline our thought process so that we do a proper architecture of these multi-agents, right? So the key differences is what I'm going to show now. So first thing is, I think the traditional microservices most of us know, it's a deterministic output. You always know if you give some X input, it always gives Y. But agents are not. Same prompt, word by word, everything is same. It will give you a different result, right? It's a probabilistic agent. So for that we have solution. We'll come to that. So similarly, it's stateless and it won't store any specific information. But agents, we have a context window. Then failures, right? Failures is very important here. In microservices or any of the normal solutions what we have, if something fails, you have error code, right? It shows this is the error code, and if somebody is working in the system for 10 years, he'll directly tell this is the reason, go and fix that, right? But agents, right? On the other hand, on agents, it is a silent failure. Nobody knows that it is hallucinating. It will confidently tell this is the output, and then if you try to correct it, it will say, yeah, good catch. Right? That's what it is. Absolutely good catch, right? You are right, absolutely right. Right? These are the statements. If that response comes, please understand it's hallucinating, right? So you have to reset your session. Please don't continue on that session anymore. So it's the most dangerous part, right? We will know only from the downstream that okay, something is failing, right? Otherwise, it won't throw any error codes or anything. Confidently tells yes, you are on the right path. Modi is the Prime Minister in 1990s also, it will tell, right? So that's how it is. Then scale, right? So you can replicate, you know, the predictable cost of a microservice. If scale up, scale down, I think everybody understands. But here the scaling is very different. So the inference cost, what we are going to consume, what is the latency, what are the token limits, right? So it's a new concept altogether for us to think of from a scaling point. And then SLAs are in milliseconds, microservices, even nanoseconds in some places. But here in agents, if you want it to be in milliseconds, you have to pay billions of dollars. Anthropic will be very happy, or OpenAPI guys will be very happy. And then interface, how do we talk to microservices? Through API contracts. It's pretty defined, right? But for agents, I can ask it in some way, you will ask it in different way. So it's a natural language process, right? And the key thing is, the most complicated language is English, right? Like not in the sense, not specifically English, the way humans communicate, right? So the words which I use, if I say do a deep analysis of this particular code, the agent will give me a different output versus do a deeper analysis, right? And also if you say some additional word, some comma extra, then your output is already drifted by 30-40%. Right? It's very natural and it's very confused and gray. Then you can test, microservices you can test, but agents, it's a different ballgame altogether. Like the evals is the one which we have to use to understand whether you are getting the intended output or not. Right? So these are the key changes which will help us to design any system, a multi-agent system. Right? And then the new primitives, these are the baselines for us to design the multi-agent system. Yeah, please.
We separate the code for the services and how in the agentic system, how do we separate this code for this and this code for this. In a single monolithic architecture, we need to maintain this agent 1, this agent 2, or this agent 3.
Okay. So yeah, so it is going to be based on the specific role. So the agents are going to be specialized personality, right? So we have to create a personality for that. System prompt is the key thing. What you will do when you create an agent, you have to make it specialized. So let's say you want to buy a home as an example, right? So you have a banking agent, like let's say you want to create a multi-agent system which will help you buy a home. So first thing would be location strategy analyst. That could be one agent. You will define the scope for it. You will define a system prompt for that, saying that you are going to analyze the lands or XYZ in this particular region, and it will focus only on that activity. Similarly, lawyer, right, like who knows the real estate stuff of RERA kind of rules. So that is what you are going to define. It will be more domain driven, you can think. It's a domain driven architecture is what you can think. And then for every specialization you will create an agent, and then you will have an orchestrator on top of that which will understand what agent to call at what time. So that's how we have to define. Right?
You mentioned something about encryption in the last slide. Can you please just go back and elaborate on that one? Yeah, for interface, you mentioned something about encryption.
Inference.
Yeah, inference. Can you just elaborate a bit on that? So in the interface part.
So in the interface, okay, so for agents, what is going to happen is you will not have any specific schema, right? So to communicate with agents, it's going to be natural language.
Right.
So always it's going to be natural language. The example what I was quoting now, I want to buy a flat or land in Embassy Tech Village area, right? So that's what I am going to put if I am going to call, right? But someone else might say, I want to buy a home in East Bangalore, right? So the definition is not fixed. So it's based on the natural request, people who wants to say, like based on their need, right? So it is going to be changed. But API you can't call it. You have to give the input saying that input 1, 2, 3, 4, 5. This is the protocol I have to follow. This is the format it has to be. So here I can give numbers, I can give location, even Gmaps.
Encryption or comma separated something in this context?
Okay. Why is schema fragile?
Okay, the output can come, okay. So I can ask, give me the output in JSON output format.
But right now I have libraries which actually will just, I can have something like a LangChain or something and define like this is how I want
That's right. So when you are designing, we should think of this. That's what I am saying. So when you are defining, we have to make this constant so that the output is always in JSON format or English readable format, whatever format we want. So this should be made constant. As of now, if I don't design in that way, it's fragile. So I can ask in JSON, you can ask in XML, somebody can ask in gRPC, whatever, right? Whatever format they want, they can pass.
One question.
Yeah.
I mean, does it mean that, the difference between agents and microservices, every agent is usually exposed or deployed in production as a microservice, right? This is true, or there is a
So from a deployment point of view, it's an independent unit which is working. But these are the differences. So when we deploy it, just don't take the microservices assumptions and that mental model and deploy it. That's what the key is.
But it's our shared memory, like multiple for the context.
Yeah.
For the context, this is our shared memory.
Yes, it will help.
Microservice plus our
So microservices have different concept. It has caches which can be used, but here the memory is different from cache because cache it will be defined. Right? You can define a structure what it is going to be there in cache. But for the shared memory, it's not safe. Right? You can store whatever information.
So when you said questions to the end, as the sessions are time boxed, let's give the host some time to walk us through the topics, please.
Okay, I'll take the question. Okay, so key things we need to remember, that apart from the differences from microservices, the key things is the context window. So I think we touched on this a bit. So context window, it's not RAM, right? So let's not think it's a RAM. So what happens is whenever the length of this particular conversation increases, LLM has a recency bias. What happens is whatever recent information I have, even though my context is whatever big it is, it tries to pick up what is the recent information it has in the conversation. It will override the previous one. So the context window is pretty important, and this is key architectural decision which will define. So how much conversation history I am going to store, right? And then when I am going to compress this particular session, right? All those will be defined based on this context. And then non-determinism, we discussed same input, different outputs. So temperature is one of the key factors we have to decide when we are defining the model. Then tokens are pretty important. I think the whole cost of your agent is going to depend on the number of tokens we are generating. Right? It's not only input, even the output. Right? So now the costing of every LLM is based on both input and output. If you write 1000 lines of prompt, that is costed. If the output is like 100 million lines, that is also costed. So we have to be efficient in how the tokens are utilized, and you should have layers which will actually ensure that the tokens are efficient. And then the blast radius. So one important aspect is if you are giving a capability or any tool for this particular agent, we need to understand one thing, like what is the worst thing that can happen when I give a capability to the agent? Is it safe enough or not? And if that is safe, then only allow it to happen. Otherwise, let's have a human in the loop. Right? So this is the key thing which we need to keep in mind. So Amazon has faced issues, Claude has faced issues, everybody started facing issues, right? So Amazon even has passed a policy saying that none of the code is going into production without senior engineering reviewing it. And that's the situation we are on. So I think those guardrails and what impact it can create is what we need to understand and then design. Right. So now we'll get into the actual reference architecture. So this is the initial layer, right? So this is the high-level architecture, how a multi-agent system should look like. We'll get into details of each of these boxes, right? I don't want it to bombard people with the next slide. So first thing is, this is standard. We all have, this is the user interface, how clients will interact, it can be anything. Then this is pretty critical, LLM gateway, right? So to which, what is my token budget, whether I am authorized to do this part activity or not. So for this one simple example is Chipotle, a US food company. Their chatbot people are using as Claude. Okay, so it is not supposed to answer specific questions, but people are asking, okay, give me a code for Python for this one. It started responding, right? so we need to understand, okay, what is the intent of the user, whether it is allowed or not. So that is what LLM gateways are. One example. It will do.
Question on that.
Yeah.
So when people were using Chipotle's chatbot to write code, they were actually using Chipotle's tokens to write
Yes,
code.
yes, exactly. Yes. So it should say, I don't know, right? Ideally, it should have said, boss, I am supposed to tell about your orders, where is my food, any problem with my order, right? But it started answering everything else also, right? So then next one is the orchestrator layer, which is the brain kind of thing, which will help decide what to happen, how many agents I should call, what should be my task, all that. Then we will have a supervisor agent. Even this orchestration, there are different patterns. I think we'll take that for another day. So then you will have specialist agents, the actual worker agents, right? Like which will do the real work, and then all these will be aggregated with the orchestrator. Then agents are not agents without tools. So we'll have a tool layer which will be again authenticated, authorized, all those activities will happen, and then the tools will be called. And you will have internal tools and external tools, and then these are the key three things, right? The knowledge layer, the cross-cutting layer of security and governance, and then the observability and events. So without all these things considered, this multi-layer, if you are not considering these multiple layers, it's not production ready. You are doing a demo production, like demo solution, taking production load, right? So we should consider all these activities and layers before designing it. Actual data. So it would be in your knowledge layer. Knowledge and memory layer is the place where which is needed for the agent, right? So for storage it will be different. Like if you want to yes. So for agent, this is the knowledge layer which will tell, like let's say for the real estate one, when the context comes as Bangalore, right? So it will look at Karnataka rules. It won't look at all India rules. So this will help agents to fetch the information from this knowledge graphs and knowledge base and then make some decisions. So it can even go to web search and then do, but these are the places which will help us to find out the actual information.
Can you just go through this diagram also? Just give us one.
Yeah, please.
30 seconds.
Please.
There are for usual websites, they are like security threats, SQL injection,
Correct.
those stuff. So for here we have intent classifier.
Yes.
Isn't there ways to bypass it, or we have seen?
So we
like
have
people
prompt
use-
injection. So prompt injection is one thing that can happen, and then your the tools, right? Whatever tools we are calling, they will try to infiltrate the sub agents and then say call a higher privilege agent. So all that would happen from top to bottom everywhere. So wherever the tool output is coming, the security will be in this integration layer. So where it will authorize and verify the intent and then give it back to the agent. And from top, intent layer is the one which will tell whether the intent is matching with the company policy or not. Like the Chipotle one, intent classifier will tell the intent seems to be not order related. So it will say I don't know.
There is no proper framework. It's just prompt deciding if it is related to whatever we are providing or not.
Okay, okay.
So post that as it's mostly help me do this, which is unrelated to whatever service you are providing, whatever. Is there a defined framework for this, or is it just every company trying to improve their prompts for it?
No, okay. So now, okay, for the agents, right? So for these agents, we will have tools, skills, then the planning, right? So, and even there is something called evals and guardrails. So even these guardrails has to be like policy as a code. In the next slide, I will try to show that. So, but the thing is, we have to define as an enterprise. The company has to define what you want to stop LLM doing, what it has to do versus not to do, right? So everything has to be defined. LLM can't imagine, and it's a generalist. It does everything, right? It can work for a lawyer company, it can work for a software engineer, it can work for even like the secretariat, right? So it can work for anything. It's a generalist. So you have to define those boundaries and then ensure you are not crossing those boundaries. That's what it is.
So here layer 2 should be connected to layer 3, right?
Yeah.
And there is no connection between layer 1 and layer 2.
Yeah. Forget about the arrows, because if I draw arrows, I started drawing arrows, then I thought because the cross cutting will be touching multiple layers. So not to confuse, I removed it. But logic is, everything is connected. Without any layer, it won't work. The solution won't work.
And where do these cross-cutting and observability fit in?
Yeah, these will be across layer, right? So you will understand from every layer what is happening, and then it will verify whether it is within the guardrails or not.
Yeah, even the observation and
Yes,
suggestion
yes.
will be in every layer.
Yes, every layer. So it has to be something like this.
Right.
So this defines the complete architecture. Okay. So the reason of showing the previous slide was that only, so that you won't get overwhelmed with the different options what we have. Right. So the first layer, I think this is pretty standard. Everybody knows we can connect to CLI, your SDK, your mobile app, web app, everything. Right? That's the standard. So now this comes the LLM gateway, right? So what LLM gateway does is, it will help you to route your request to, let's say OpenAPI is down, right? So this LLM gateway will know that my response rate from OpenAPI is pretty slow, or it is failing, I am not able to reach. Then you can have a fallback saying that okay, my OpenAPI gateway is down, then go to Claude, right? So go to Anthropic APIs, right? Call those. So it will help you define those particular resiliency layers as well, and then it will do semantic caching. So these are the different boxes which we have. So I'll try to explain it. Right? So first one is on the. So the LLM gateway first activity is like it will do the authorization. Whether the request which I am receiving, is it my customer or not, whether he is authorized to do this specific activity or not. Let's say it says fetch the database values of my colleague information, right? It won't tell, right? This itself will tell you are not authorized to do that. Similarly, it will do rate limiting. So somebody is trying to hack, like DDoS kind of action they want to do, and then create a lot of requests. So it will do the rate limiting. And then here is another important called PIA redaction, right? So the personal information whichever is coming inside the system, until unless it's needed, please don't pass it there, right? So it will remove that particular information and then send. And it will verify the budgets, right? Whether you have reached, so for your solution, for a user, for time pass they are doing chatting with your agent, right? So that should not be allowed. So for a day it will say, you have reached your limits, please don't waste my tokens, right? So it will try to do the cost controls. Then it will do the model mapping also, whether it should go to which model based on the response times and the availability. Then the semantic caching, majority of the questions would be similar, right? So like let's say 30 to 40% of the questions would be similar what the users are using. So this semantic caching will help us to respond the same response. So it is not calling LLM. It will see if this response, for this question, do I already have the response? So it will just respond back like caching, similar to the caching, it is a semantic caching. It will understand the semantics and then respond back. So it will reduce your cost further. And then it will do a logging of different prompts requests that are coming. And then the output safety as well, like it will ensure you are not sending back any critical information, any personal information. So it will do that redaction. Then the intent classifier is the next one, which will say whether this particular intent is matching. We just spoke about the Chipotle example. This will help us identify whether it should go further or not, it's matching the intent defined by this particular company's policies or not, and then it will send it to orchestra. Otherwise, it will escalate to human, or it will say I don't know, and then close that. So then, arrow is here, again. Yeah. So I think the previous one is missing. So similarly, the orchestration layer is the brain which will actually think of the given problem, whether it's complex problem, do I need sub-agents or not, what should be my task plan. It will do the complete planning, right? So for this one we can using the LLM gateway, we can use this Opus or the new big models which are coming, and then it will have a plan tracker, it will do the agent state, and then it will call the supervisor saying that this is the task plan, and I know these are my, and agent registry is pretty important. So example is orchestrator should know what are the sub agents available, right? And we should not hard code in the any code what we are writing. So agent registry will tell if you are adding new agents also, it will be in the registry, and then orchestrator will know for this problem I can give to this task can be given to this agent. So once that is done, it will go to supervisor. Supervisor is the one who will decide parallelism, saying that okay, for this activity I can do 6 tasks. Out of 6 tasks, 3 tasks can be done in parallel. Others can't be in parallel. It has to be sequentially. It will decide that, and then the actual specialization agents will come, right? So in our example, which I was taking, the lawyer agent, then the area analysis agent, right? All that would happen. This is the specialized agent. So this will allow to focus and the quality of output will be pretty good if we have the specialized agent. Then specialized agents will also know what are the tools. So this is the tools layer using MCP or different protocols we can connect. So this will define the tools it has to be connected. And the additional thing what you will have in this particular integration layer is the authorization. Right? So whether am I calling the right tool or not. So there were few scenarios where LangChain is also, the CVEs were created, the security threat has come. The tool started giving additional information which manually we can't see. So in white text it has given that, and then all the secrets have been sent back. Right? So this will analyze, this layer is importantly from that security angle as well. You will authorize whether you can call the tool, are you giving the sufficient information to the tool, and are you getting more or less, right? So similarly, I think output validation, usage limits, right? All those activities will come. And then this is the knowledge layer. So it has the context L1 where there are multiple levels of knowledge what it can store. One is the context memory which is needed for that particular session. Then you have an episodic memory, like for a specific user, different conversation will be compressed and then showed to the episodic one. Then you have a semantic knowledge, right? And then followed by multiple, so this would be your knowledge base from a session and also specific domain, right? So, yeah, go ahead.
Memory wise, right? So the second level of memory, right, which is specific, will you going to store it somewhere in Redis or somewhere, or is it like individual?
The knowledge layer.
The second one.
Okay, okay, so there are multiple solutions for that. So Redis is also one of the options where you can store the information. You have a knowledge graph, like you can create knowledge graph so that you get the accuracy of info. Then you can use Neo4j. So there are different options for us to do. Even Chroma is one solution, KuzuDB, like there are different solutions available for you to do this. Right? And on top of all these memory related ones, which are needed for a specific session, we can have the knowledge base stored, right? So let's say there are law companies who knows more information than what you have, what you see in the public knowledge, right? So all those information they can store in the knowledge graphs, and then that will help the lawyer special agent to actually fetch that information and give a more accuracy response, right? And then and following that, the actual tools, these are the external tools like web scrapers, the file creation system, CRM connection, cloud connection, right? All those different tools can be there. And then the security and governance is pretty important to ensure that it's not screwing up on production, right? So this is where the governance layer will come in. It will define what it can do, what it can't do, right? And this list has to be dynamic, so that's where it's a policy engine is what we need to have, like OPA kind of solutions, where you will define, okay, initially you might not know what it should not do, but human in the loop is what you need to consider for every activity, and then slowly make it automated, right? So I think you should progress step by step and then ensure you're limiting the agent to do activities on production as much as possible. And then slowly when we are reaching that maturity level, then make it more automated, right? So similarly the trust guardrails, then the audit rails, and even the supply chain attacks, right? So you should, so the recent issues what we have seen, like LLM Lite is hacked, right? Axiom is hacked, everything is like security breach, right? So we should pin our versions to ensure that we are not using auto updates, all those we should off. So this security layer is pretty important from the supply chain attacks also, the vulnerabilities. And accordingly the compliance layer, so depends on the domain, like banking has some compliance which we have. If it is a PCI DSS solution, it wants some specific activities to be stored, and when the audit happens, we have to show all those information, right? So the compliance requirements also should be there. Then following that is your observability and evaluation layer. Evaluation layer will tell us, it will collect traces. I think this is the regular one where you will collect traces. What is the thinking process of agent, why it made the decision, all that information will be there. And following that we will have alerts, like if it is deviating from any specific intended output, you will start getting alerts, right? The regular observability. And evals is the key thing here, where you have to ensure that the output which is being given is matching with your intents. right? So the evaluation layer, there are multiple solutions for it, and then this will, with all these layers, if you go to production, then it is production. Otherwise, it's not production. It's a demo agent. Everybody stops this layer, right? So we create a specialized agent and then say we are ready and then go to production, which is going to create a lot of problems, right? So let's not get there, and we should ensure all these different aspects are put in before you put into production. Yeah, go ahead.
In the semantic you mentioned, right? So in the previous
Semantic,
slide,
yes.
yeah, the second layer.
Yeah, correct.
So you mentioned that in the previous slide that the same input may not have to be a same response.
That's what semantic is. Okay, so what it does is, semantic is like this, right? So I want to show me the apartments near Embassy Tech Village. Okay, that's one thing. My intent is to find out, so if I look at longitude, latitude, right? So at this particular longitude, latitude, I want to find the apartments near me. That's what the intent is. So similarly, one person will ask, show me the apartments near Embassy Tech Village. The intent is matching to near this area, Kadu Bisanali area. Then the second person will say, show me near EcoSpace. The intent is still same, right? I am near this longitude, latitude, 30 meters, whatever. So the response can be same, right? So that's what the semantic matching will be. So it will try to find out what user is actually trying to get. I want to know from like in this area, right? So 1 kilometer radius is what it will understand, and it is near to this particular longitude, latitude. So we can give the same result. So that's how you cache and rest.
If the question is get the apartment details in Bangalore, then that
It
will
won't
not
work.
use that semantic.
No, it won't. So it depends on the closeness of your question, right? So EcoSpace and Embassy Tech Village are nearby, so you will get the same response. But if I tell JP Nagar, it won't show. It will again fetch.
Now, taking the same example, what you said was the two people are asking the same thing.
Intent, when intent is
Yeah,
same, yeah.
that's fine. I'm saying this, but internally it will actually sort of do a Google Maps API with a radius thing.
Yes.
So it doesn't really use.
It won't call LLM. Yeah.
That's what a tool uses.
Yes, exactly. So the tool will decide the intent classifier, right? I use a small LLM there, which can be even self-hosted, right? I can use like Gamma 4 kind of thing I can use, and then get the intent, then you call the actual one.
Actually,
Yes.
yeah, which can be just an API call
Yes.
for tool and you can.
Correct.
Right, so that means that.
So it does actions. Like it will try to identify the intent, whether it will check whether how close it is, then it will decide what to do.
So in this layer, each user is providing the prompt. Now it is a multi-agent prompt. So how the multi-agent getting the information for it?
So that's where the orchestrator and supervisor will come in, and then it will say, so orchestrator will define the plan. Okay. So orchestrator will define the plan. These are the 6 agents you have to use to achieve this particular activity. And then supervisor is the one who is going to pass that information. So for lawyer information, it will send only lawyer related information. It won't send the whole prompt or the whole intent altogether. So supervisor will ensure what information is needed for that agent. It will pass it, get the response, then it will coherent and like summarize the responses and then go back to the user.
So actually it's my prompt and they are making segregations. So my
Yes.
prompt is going to be where?
Correct.
Not rephrasing the.
No. And few solutions do the rephrasing of prompt as well to ensure it is consistent and it gives the actual response. That's where the reasoning or thinking models come in. So if you use old models, there is no reasoning or thinking there. They will just copy paste whatever you have given. But now with orchestrator using high thinking and reasoning models, it will enhance your search, saying that okay, this is what the user intent is. So he might want this information as well. Let's say what bank loans are preferable, right? So it will try to enhance it and then send. So the more thinking and reasoning you give, you are giving liberty for that particular agent to think more and then pass it further. So if you reduce the thinking level, so you have thinking levels for models, right? So high, low, medium, max, right? So based on the thinking, it will manipulate, or it won't manipulate completely, but it will enhance that particular request and then pass it down. Yes. So model selection is again through LLM only. So it will decide based on the quality of task, complexity of the task. It will decide whether I should a higher model or lower model or which is self-hosted. No, it won't select. No, it is agents. Okay, agents will use LLM, right? So here we are deciding what agents should be involved in this particular activity. I can have 20 agents. Yes, everything I'm using it. Otherwise, it will again manual way. So it's all powered by LLM. Yes, correct. So supervisor to agents will be A2A, and if something needs to talk between those, then it will be. When agents are talking, you need A2A.
First question is, since we have so many agents, right, multiple layers, there would be a lot of latency involved in getting the response. Is there a way we can reduce that, or is that some trade-off that we have to do?
Okay, so one thing is the LLMs are usually slow when there is a thinking mode, more of thinking. So that's where we are trying to keep everything at one place. Orchestrator is the place it will consume majority of the activity. Then these are specialized activities where usually, let's say if you have asked the same LLM to do, that's what the Anthropic case study I was mentioning, right? So if you ask the same agent to do the full 10 tasks, it will take 10 hours. But by doing this planning and then doing this parallelism and different agents coming in, it will reduce your time to 1 hour. Right? So it depends on the complexity. Eventually there is a trade-off of latency. It won't be as big as microservices, but it is reducing reasoning, everything is happening. So there are advantages.
But do we have any specific pattern?
So there is a second question here, then we will come.
Since we are, so this system is very dynamic in nature. So is there a way that we can estimate the cost for this entire system? Because microservices minister, if I put directly, right?
Yeah, so the solution is in your guardrails and the budgeting, right? So it will stop after, let's say, some user is asking a question which is going to consume $5,000. It will stop there, right? Because you have the budget defined, like the number of steps it has to take. So in Orchestrator, like I wanted to mention this one. So this plan tracer, right? So it has a budget control, right? So step budget, the token budget, cost budget. So it will monitor all those and it will stop at that particular step. Yeah.
How do you cache frequently asked questions or similar questions that have been asked before?
Yeah. So okay, it is going to be semantic. Eventually, semantic caching is what is happening. It will load, right? So we can define, let's say you can define the logic saying that if a token usage of a specific query is beyond, let's say 10,000 tokens, right? That can be my first filter saying that anything which is taking 10,000 tokens, please keep it in the cache, right? Once that is cached, if I get a similar intent question, then it will respond. So that's how you can filter instead of loading the whole information, right? So you can have those logics defined and then your answer.
So prompt for the single agent and the multi-agent. We have some different pattern to the prompt for the single agent or for the multi-agent.
A prompt is always same. Orchestrator is the one who is going to take care of the dividing that prompt into tasks. Which agent will do what task? It's all done by Orchestrator. For user, it's all black box. They will just put an intent saying that I want to buy this flat near this area. That's it. So backend, all this is happening. Prompt will not change based on single agent.
So when we are giving a prompt, right, do we need to specify the orchestrator name as well?
No need.
Simple.
Everything is passing through Orchestrator. So Orchestrator will decide. So even if you see here, right, so there is a path saying a direct agent call. If a specific prompt needs only one agent, no need to call supervisor agent and it will directly call a agent, then resolve it and then send it. Orchestrator is your brain, which will decide should I give this task to 10 members of my team or not.
So you talked about prompt caching, right?
Yeah,
So
it's not prompt caching, it's response caching, like semantic prompt caching.
So how does it ensure that the new prompt that we are actually putting up, right, gives the relevant response? Because the older one might have been outdated and all for some reason, right?
So it is a semantic prompt that is getting stored. So if a user asks, find me the apartments in Belandur area, right? So I might ask, find me the apartments near Embassy Tech Village. You might ask, find me apartment near EcoSpace. Your prompt is EcoSpace, my prompt is Embassy Tech Village. But what is actually getting stored is Belandur area. Apartments for Belandur area is what is getting stored in the cache layer. It's not the actual prompt, it's the intended prompt that is getting stored.
So the interesting point here is matching the various intended
Yes,
prompts
yes,
and
that is
various-
what semantic matching and semantic
And
caching.
be able to figure that out.
Yes, but using LLM it will do. Like there are multiple protocols also to do that.
But the token consumption is still the same. Like it's
No, because let's say I am the first person to, we are running out of time. So I am the first person to ask for MSC Tech Village. I will consume, my question will consume the token because it is going to LLM and getting the information back. When you query, because your intent is already there, it will fetch from cache and give. It won't consume LLM. There is no token consumption. That's the advantage.
So, my understanding is since the prompts are getting vectorized, ultimately it's doing some
Yes.
kind of similarity
Yes.
matching
Exactly.
between the prompts to understand that it's a similar.
How close you are to
So it's
okay, then just 1-2 minutes, I will close my talk, then you will do. And the key takeaway, right? This is the key takeaway which I want you all of you to think of. So these are the 12 factor methodology what we are, right? Similar to that is what it is. So you have 12 things which you need to keep in mind. First, try with single agent. If you are exhausting it, you find all the issues what I am explaining, then go for multi-agent. It's very costly affair and it's not easy, right? Like I have shown 9 layers. If somebody would have counted, all 9 layers has to be there, otherwise your production is in soup, right? And then already layoffs are happening, let's not get more trouble. Okay. So then LLM gateway is the thing which you have to have, which will bring all those advantages I was mentioning. Then classifier, then the registry over hard coding, which is the agent registry. Let's not hard code anything in the orchestrator or everything. Then trust is explicit. You don't trust anything, right? Tools you don't trust. If it is from OpenAPI also don't trust, right? Ensure there are some security guardrails. And then budget is everything, right? If an agent runs and then it is consuming $22,000, then like you will be getting a red letter, right? So then next thing is blast radius and the gateway for all tool integrations. Don't call tools directly. Try to aggregate wherever possible. Ensure the authentication, validation, all that is happening. Then the observability is very important. Already LLMs are black boxes. If you don't have observability, then you can't even answer your own solution, right? So then evals is definitely needed, whether the intent is matching or not, all that has to be done. Then human in the loop is what the default has to be, and then slowly make it automated, right? Don't go directly, I'll go to 200% automation, don't do that. Then pin your models. If any model change, right, like I was mentioning, if a word changes or comma is extracted, output is changing, then imagine the model getting upgraded from Opus 4.6 to 4.7, your whole output will be haywire, right? So pin your models, pin whatever tools you are using, pin that particular version, and then do a manual validations and then upgrade it whatever you want, right? And with all this is the last slide, okay? So these are the different tools which are available for the different layers I am mentioning. Like there is, for the UX you have chain lead, then you can have a custom React, then there is a stream lead radio, right? So every layer you have, I think, yeah, better take a photo. We are running out of time.
Can you share the slides also?
Yeah, yes, sure. Okay, then before that, right, before putting anything, okay, security, supply chain security is under attack. We have all your passwords, everything is already there in multiple places. Don't use any tool without validating their security levels, right? So, Light LLM is one of the LLM gateway, right? And it is attacked recently and nobody knows. And it has attacked through Trivi, which is a dash tool, which is the security company itself, right? It got attacked through that. So similarly, LangChain, LangFlow, MCP, right, everything is impacted. So please be sure putting into production, you validate with your security teams or ensure your CVEs are already fixed and then go. Only stable versions is what you are going to take, right? So please be cautious on that. Thank you. any hands, so we'll discuss.
Please.
Yeah, this is my LinkedIn. Please connect, send me questions in LinkedIn.
There'll still be a 15 minutes break. We'll be starting our next talk at 3:30. So you can still ask as many questions as possible.
You need to design an agent architecture to get answers to his questions.
That was a very wonderful session, Kishore. Please do accept the small gratitude. Thank you. We'll just have a short break.
So
3:30.
before that, I think they told me I have to give some chocolates. I forgot. But yeah, I heard many questions. You were asking some questions. You were asking.
I also asked.
I think last row somebody was asking.
We all ask questions.
Please pass it on. Don't keep it. Give to that person in the room. He was also asking.
Kishore.
Hope it's not, can I get a chocolate?
I saw you were sleeping.
In that case, let's get back at 3:30. Let's just take a short break.
Wasn't there a quiz also?
Yeah.